Every single time you connect your phone or your laptop to a network, there's this invisible, super fast process that just makes it all work. It's called DHCP. And honestly, it's one of the biggest unsung heroes of your entire digital life.
I mean, seriously, just try to picture this for a second. You get a brand new phone, you're excited, you try to connect to your Wi-Fi at home, and instead of that simple password box, you get this terrifying screen asking for your IP address, a subnet mask, a default gateway. What on earth would you even type in there? For most of us, that's just game over, a total dead end. Well, that chaotic nightmare scenario, that's what life would actually be like. Without DHCP, every single connection would be a painful, manual chore.
All right, so to really appreciate what this hero does for us, let's dive into the world it saved us from. Let's talk about the chaos of manual connections.
And it was, I am not exaggerating, an absolute nightmare. You'd have constant IP conflicts. That's when two devices try to grab the same address and, surprise, neither of them can connect. You would have to manually punch in the settings for every single device, your laptop, your phone, your new smart TV. Forget just giving your aunt the Wi-Fi password when she visits. You'd basically have to be her full-time, on-call IT support just to get her online.
And this right here is where our hero, DHCP, swoops in to save the day. DHCP stands for Dynamic Host Configuration Protocol, and it's the system that automates that whole messy process. It's the magic built into your home router, it's running on servers in big companies, and it works quietly in the background, just handing out all the right network info so you can get online in like 2 seconds.
Okay, so how does this magic actually happen? Well, it all comes down to a super fast 4-step process. We call it the DORA handshake. And really, you can just think of it as a quick, polite little conversation between your device and the network.
That acronym, DORA, stands for Discovery, Offer, Request, and finally, Acknowledgement. Let's break down exactly what happens in each one of those steps.
All right, first up is discovery. So your device connects to the network, but has no idea what its address is. It's like showing up to a party and not knowing anyone. So what does it do? It basically shouts out to the entire room, hey, is there a DHCP server around here that can give me an IP address?
And what's really cool is how it actually shouts. See, every single network device has a unique physical ID, kind of like a fingerprint, called a MAC address. To do this broadcast, your device sends its message to this one special MAC address, which basically means, hey, network switch, send this packet to everybody connected. It's the perfect digital equivalent of yelling across a crowded room. So somewhere on the network, a DHCP server hears that shout. It goes, aha, I can help. It looks at its list of available IP addresses, picks one out, and sends an offer back to your device. And this offer isn't just the IP address, it's the whole package. It includes the gateway to get out to the internet and the DNS server addresses, the internet's phone book. And that's step 2, the offer. Now, your device is probably going to get that offer pretty quickly, and it'll usually just take the first one it sees. Then, it sends out another broadcast. This is the request. This time it's yelling, hey everybody, thanks for the offers. I'd like to formally request the IP address that this server offered me. It's also a polite way of telling any other DHCP servers on the network, hey thanks, but I'm good, you can take your offer back.
And that brings us to the final step, acknowledgement. The server that got picked sends one last message directly back to your device. This packet is the final confirmation. It basically says, you got it, that IP address is officially yours for a set amount of time. And we'll talk about that lease in a sec. Welcome to the network. And boom, just like that, in milliseconds, you are online.
But DHCP is way more than just this little 4-step dance. It's got this whole toolkit of other features that network admins rely on to keep everything running smoothly, especially when you get into bigger, more complicated networks. Let's look at the hero's toolkit.
Okay, remember how I just mentioned that lease time? This is a really, really important concept. Your device doesn't get to keep its IP address forever. It's really just borrowing it. And for most networks, the default time for that loan is 8 days. So why is this lease time thing such a big deal? Well, think about it. If you're running the guest Wi-Fi at a busy coffee shop, you've got people come in and go in all day. You'd want a really short lease, right? Maybe just a couple of hours. That way, IP addresses get recycled quickly for new customers. But in an office, where it's the same laptops connecting every single day, a longer lease, like that 8-day default, makes a lot more sense. It's just more efficient.
Okay, so here's a puzzle for you. What happens in a giant company network where your computer is on one floor, but the main DHCP server is in a data center somewhere else on a totally different network?
Remember, those shouting broadcast messages can't cross over routers. Well, that's where something called a DHCP relay comes in. The router basically acts like a messenger. It hears the shout, picks it up, and personally forwards it to the right server, no matter where it is.
But wait, that leads to a really good question, doesn't it? If you have one big server handling requests from, say, 10 different networks, how in the world does it know which IP address range to pick from for each request? It can't just hand out a random one. That would cause chaos.
The answer is actually pretty clever. It's a feature called scopes. Here's what happens. When that relay router forwards the request, it tucks its own address into the message. The DHCP server gets the message, sees the router's address, and goes, that request came from the third floor network. It then looks up its pre-configured list, its scope, for the third floor, and grabs an IP address from that specific pool. It's a super elegant way to manage huge, complex networks from one central spot.
Of course, with any system this important, you have to think about the dark side. What happens when someone tries to hijack this nice, smooth, automated process for bad reasons?
Yeah, this is not a small problem. There's a quote here from a network admin that sums it up perfectly. Rogue DHCP servers are a nightmare. And these things, basically unauthorized servers that just show up on your network, they can cause some serious trouble.
A rogue server usually shows up for one of two reasons. The first is just an accident. Incompetence, you could say. Someone brings their little home Wi-Fi router to the office and plugs it in, not knowing it's also a DHCP server. The result? People start getting the wrong IP settings and suddenly can't connect to anything. Annoying, but fixable. The second reason, though, is much more sinister. An attacker can deliberately set up a rogue server to pull off a man-in-the-middle attack. They give your computer bad info so that all of your internet traffic gets routed through their laptop first, where they can read everything. Your emails, your passwords, everything.
So how do you defend against that? Well, the best weapon we have is a security feature called DHCP snooping. The best way to think about it is like a bouncer at the door of your network switch. You tell the bouncer, hey, only DHCP offers that come from this specific port, the one plugged into our real trusted server, are allowed in. If an offer shows up from any other port, blocked, dropped. The bouncer just throws it out. It's a really effective defense.
So when you put it all together, that DORA handshake, the smart use of leases, the organization of scopes, and the security of snooping, DHCP really does become this quiet, totally reliable foundation for your entire network. You know, DHCP is just such a perfect example of elegant engineering. It works flawlessly millions, probably billions of times a day, all so we can connect to a network without ever having to think about it. It really makes you wonder, doesn't it? What other invisible processes, these other unsung heroes, are running in the background right now, powering everything else in our digital lives?